Well, good afternoon, everyone. This is Melissa Parsons, VITA-ISP Regional Coordinator for Region 3 and 6. Welcome to our next series of Webinar Wednesdays. And today's topic is going to be getting your GIS data from here to there, processes and best practices for ETLs. During the fall of 2019, ISP staff delivered workshops across the Commonwealth, and this session is going to present information from the workshops related to the ETL, best practices, and methods for data schema comparison. If you all are on the line, you should have been muted when you joined. You do have the option to hit *6 to unmute, but we would appreciate it if everyone would stay muted and utilize the chat window, or unmute yourself by *6 if you would like to talk. But if everybody could go ahead and hit #6 on their phone to continue the mute, hopefully we won't have much background noise and we don't take away from the webinar in that case. So again, please hit #6 on your phone to mute your line. If you need to talk, I will monitor the chat window, or you can hit *6 to unmute. And today's webinar is presented by our Geospatial Program Specialist, Matt Garricky. So with no further ado, I'll give it over to you, Matt. Thank you.
Thank you, Melissa. So as Melissa said in the introduction, what we're trying to do is take some of that material from the fall webinar and provide that, or from fall workshops, training workshops, and provide that in a webinar format, modified a little bit based on different things that we've learned going through the course of the fall trainings, as well as we've learned more about the next generation 911 deployment and the GIS requirements for that in the Commonwealth of Virginia, and also providing it as a recording that will be made available on the ISP website for reference. If you're able to attend one of the fall trainings, that there is similar but also a little bit different material and content, and we're always fans of keeping things kicking forward and rethinking about things, and trying to assemble reminders and stay on the track of where we're at and where we want to go as we look at our GIS skills and the different ways that we implement and practice them. So we started with this concept of ETL because it is not particular to GIS. It's not. It's probably more of a broader information technology or data management, database skills type concept, but it's something that GIS folks do all the time. And sometimes we do it without even thinking about it, realizing it. We do it on small projects, we do it on small tasks, we do it on larger projects. And so what we wanted to do is pull together some of those different strands and not think of it as, hey, these are the routine GIS things that we do to accomplish these projects, but here's a way of stepping back and thinking about what we do as a part of a lot of these projects from a different perspective, from a different viewpoint, and use that opportunity to think about process, think about best practices, and think about some tips and tricks that may be useful. A lot of the lens and examples come from the next generation 911 experience, but we also work in a few other examples and stories, because we know that while these perspectives will be really useful for where everybody will be at and be going through with next generation 911 in the Commonwealth in the next few years, it's also really applicable to a lot of other ways of thinking about things and doing things. So that's a little bit of the background and some of where this came from. But extract, transform, and load is a concept as an umbrella term, really deals with the problem and the business case and the workflow of we have data sitting in one bucket and it does its work there just fine. It may come from any number of different places, but that's data that we have there in one database or one file cabinet or one feature class or one web service or one shapefile. And we have a new request, a new task, a new project, a new software implementation, a new analysis where we need to take that information that we have as a starting point and move it. And in that process of moving it, maybe adding things to it, removing things from it, reformatting the values that are in there, and loading it into a new target file cabinet, geodatabase, shapefile, map, service, software system, what have you. And so ETL is really the process of understanding what we have, understanding what we need, and thinking through that process of data transformation of moving from our source data sets into our target data sets. One of the experiences that I had working in local government several years ago that really got me thinking about this as ETL instead of just another part of a GIS project is when I started with the locality. We had a legacy ERP master address system that had all of our street dictionary, all of our addresses, had domains for street types and whatnot, but it was all flat files. And that really drove the permitting, licensing, and utility billing systems. And we had a kind of parallel copy of that that was supposed to be one-to-one for the active addresses that really served as our city GIS master address database. And so if there was an active address in the ERP master addresses, we also wanted to have a point representation of that in our GIS master addresses. And we had a subset of that GIS master addresses that we fed to our regional GIS master address. And so we only sent over the subset of our master addresses that were 911 eligible addresses, because that regional GIS fed the CAD system that the 911 center in the county used. And so we started there with that landscape, but several years in, there was an effort to replace the ERP system with 4 different best-of-breed software solutions: core financials, licensing and permitting, CRM to support a One Call City Hall project, and then the utility billing system. And as we were going through this transition, we still had to keep our GIS addresses in sync with the legacy system because these new systems came on at different times. And we needed to continue to send them over to the regional GIS addresses for the purposes of public safety. But for me personally, it really became an ETL project, because we weren't talking about we need to keep our addresses in sync across these 4 different software solutions, but it really shifted towards a GIS-centric philosophy. The GIS was going to be the source, the one version of the truth of where we had active addresses in the city. And we needed to not only send those active addresses to each of those 4 different new software systems So they had the best accurate record of addresses to do the different things that they needed to do with licensing and permitting and utility billing and CRM records and the core financials and some of the billing stuff that went in there. But we also needed to have a strategy so where the GIS addresses kept flowing from that center GIS-centric address database to the core financials, to the licensing and permitting, to the other modules. And so it wasn't we do it once and dump it, but we need to move it and then we need to keep it updated so that all those different systems would be synchronized with the most accurate current addresses. If a new address got assigned and it went into GIS, it needed to work its way around to those other systems as well. And so that process of, wow, how are we going to do this? How are we going to plan this out? What's this going to look like? What tools and processes and pieces, what data is needed where, really opened up my eyes to this concept of ETL and thinking about how do we approach this as a project-based problem. In talking with other localities around the Commonwealth, as we were preparing for the fall trainings and even this webinar, I got a great email from somebody that shared with me that, well, one of the things that we're trying to do is pull down 5 different flat tables from our code compliance system. And we want to automate the geocoding of those and automatically change those over into GIS points so we can visualize that data as map data from that code compliance system. We also heard some stories about folks that track assets that the locality is responsible for maintaining in GIS. Road center lines, curbs, sidewalks, manholes, meters, poles, what have you. And the GIS was the system of record for the geometry and unique IDs and some of the core attributes of each of those different assets. But they also had an asset management system that needed the geometry, needed some of those core attributes, and then added on their own attributes for the purposes of work orders and forecasting and where and all those different things that you can make GIS do, but sometimes a standalone asset management system does a much better job of handling that. And so it was a need of how do we take our asset data, how do we move it over, and how do we keep those in sync and let each of those do what it does really well. Other examples of folks of sometimes the software that you have or use that isn't GIS has map stuff. A lot of the CAD systems that we see in 911 centers across the Commonwealth are like this, to where once a month, once every 2 months, somebody pulls together all the GIS data that the PSAP needs, and then that gets moved over and that gets updated on each of the call taker workstation systems because the software that they're running and how that's tied into, that may not be tying back to the source GIS server. It may be sitting on a local copy or a PSAP specific server. But it's kind of moving data and updating it in different places for different purposes. And there are a lot of different examples all over the place of how sometimes the GIS data is pushed out, how sometimes data that comes from another system is pulled into GIS. Sometimes it's updating data, sometimes it's the mix and match. But just trying to understand where that data starts from and where you need it to go and what it needs to look like when it gets there to meet a particular purpose. So the best practices that we pulled together and wanted to share with you kind of go through a few different steps of this. Verifying the sources and targets, where we start, where we want to go, and some of the considerations that come into evaluating those. as you start to get your feet under you with knowing your sources and knowing your targets, usually there's some strategies where you need to do a deeper dive into the schemas and think about or look at potential field mappings. And usually at that point, working through those two steps, you're probably ready to make a few different decisions based on what you found. And those decisions kind of lead you two different ways that will really suggest some of the other choices that you make and how you may plan, design, test, validate, execute your ETL strategy for your particular purpose. Depending on some of the circumstances involved and some of the business cases, it may make sense to automate your ETL process, and we'll touch on some aspects of that as well towards the end. But in terms of getting started, if we're looking at moving something from one place and moving it over to another place, the starting point really has to be verifying what that starting point is and understanding what you want to move that to. When I started in local government, we had 3 different authoritative road centerline GIS data sets. They all served slightly different purposes and all had slightly different use cases of how they were developed and why they were used, but they were 3 completely valid road centerline data sets. And it took me a little while to figure out why each of those 3 was there and how it developed and why it developed and what it was used for. But if something came in where I needed to use a road data set to do a network analysis of something, or I needed to use a road data set to make a map of something, I really needed to understand from those 3 different potential source data sets which one was really the best data set to use for that particular task. One of the other elements that we see is the attributes that live in data. As I was preparing for the fall workshops, I did some Googling for examples and found an example from the city of Danville, Virginia, where they did an RFP back in 2016. And they were looking for GIS-based software for the design and management of electric infrastructure. The screenshots are pulled from the addendum to the RFP, which happened after the RFP went out on the street. A bunch of the vendors looked at it, sent in questions, and then the addendum was the compilation of the questions and the response. But one of the questions from the vendor, from one of the interested bidders was, well, in order for us to really evaluate our solution and what it may do for you, we really need to have an understanding of where your data is currently sitting. Is it in GIS? Is it in CAD? Is it in something else? What attributes do you track in your current system, and what attributes do you want to carry over to this new system? You know, the company was really trying to understand what the source data was, so that they could assess the suitability of the target solution that they would provide through a response to that RFP. And so these are 2 tables from that section that's going through the customer location information and then the meter information on the electric side that were attributes that Danville was tracking that they were also looking for a solution for, or the potential vendor was looking for a crosswalk or a way to match that data coming over. It's really about understanding the source and thinking about the targets. Software implementations are always a great example of this. And this is another example from some InterGov permitting and licensing software. This example is from Illinois, but I know that there are a few localities in Virginia that are using or implementing this. And one of the things that Intergov does is that it uses ArcGIS map servers to tie the information to a location. And so if it's really easy to go out and Google for ArcGIS REST Intergov and find different examples of how different localities have met the different needs and requirements of what these Intergov map services need based on the data that they already have in their existing GIS data and how they implement that and how they make it work. In the same vein, for those of you that are working with the Virginia Next Generation 911 deployment, which is a massive project way beyond GIS, but it has a critical GIS part to it. And that's the GIS project where staff from localities start working with AT&T or their GIS subcontractor Intrado through this process of loading up the GIS data that the locality has up into the GIS and the cloud solution that will drive Next Generation 911, field map the locality field names to the field names that need to be populated in the EZNet system, and work through the error resolution process to make sure that the critical errors that would impact geospatial call routing are resolved. It's very much an ETL process in terms of what data layers and attributes does any locality have in their GIS or as fields in their GIS data, and how do they match and how do they match up with, how do they field map over to what the requirements of the NG911 system are. And the heart of the GIS project is really walking through this ETL process from the locality data over to the NG911 system. But the starting point for some projects, and NG911 is a great example of this, is sometimes it's not about what fields you have in your data sets. Sometimes the starting point is what data sets do you need? What GIS layers are required? And this is certainly something that we're running into with the NG911 project. And it also provides another useful perspective. For example, almost everybody has address points and road center lines. We use them right now in PSAPs and the map display to help figure out where the caller is and what they're near and find out where they're calling from. But they serve many other purposes in a locality currently. And the purposes that they're going to serve in the NG911 EZNet are also going to be new and different than the purposes that they're serving now. And so sometimes it's useful to think about, okay, we have it, but what's it doing? What does it need to do? What does it continue needing to do besides the current purpose of this project, of this process? Sometimes other data, like PSAT boundaries or law, fire, EMS boundaries, those are also used in local PSAPs. The EZNet use of those is changing a bit also. And they tend to exist, but may not always exist in the same form that they're going to need to exist in for NG911. Law, fire, EMS response boundaries in particular. It's a little bit more simple what the EZNet requirement is than the data sources that folks usually use for that layer. And then sometimes there are requirements for new systems that have newer, different names that you may not be using at all in your local PSAP. The concept of a provisioning boundary or an authoritative boundary that really is the GIS core of how the GIS and NG911 is going to work. And you may not have it, you may not be using it in your traditional PSAP, but you may have another data layer. The jurisdictional boundary is what we're seeing pop up is the most common. That may be the closest proxy, the closest starting point, the data layer that you already have that can kind of meet that purpose for this new project, for this new task. And so sometimes the starting point is not the attributes, but the data layers themselves and seeking to understand them. Seeking to understand the target, if it's a smaller project or analysis, usually depends on a scope of work or a detailed conversation with the person you're doing the analysis for. If it's software implementation, the understanding the target is usually going to be in some sort of technical documentation where it will lay out what the system does, what the system needs to do, the requirements of the data layers, the requirements of the attributes. The NG911 project has several different layers of these. The one on the right is the broader detailed functional interface standards for the NINA i3 solution. And so this document goes in the weeds for if GIS data is uploaded, how does the next generation 911 system take that data and move it into all the other different places that it needs to go for the NG911 geospatial system to work. The one on the left is the NINA standard for NG911 GIS data model. It lists out specifically what the required GIS data layers are, what attributes it expects, and what way those attributes look, and what's needed now and what may be needed in the future to make that work regardless of what NG911 data provider data system you're moving to. As you're working with NG911 deployment and your locality signs on with AT&T or another service provider, and you get into the timeline for working on that GIS project aspect of the overall deployment, AT&T in this case, other vendors would do a similar thing, send out their own user guide for their own system. And so AT&T sends out the 911 ETDMS user guide software release 3.3. And what this document really is that it reduces the NINA GIS data model and focuses particularly on the elements that the AT&T solution needs to operate or function. In some ways, it's very similar. In some ways, it's kind of a repackaging of the data model, but it really comes from a different perspective of guiding you in how a particular vendor is implementing the broader standard. But all three resources can be useful if you're working to understand the targets. Some of what you'll find if you look in this documentation or any documentation of this sort are you usually find the list of required feature classes, and then for each required feature class, what attributes it needs, what fields it expects. Usually the requirements are spelled out about if it uses this field name, must you use that field name, or is that kind of flexible? And especially in cases of systems that date back to when shapefiles were the standard, where we're limited to X number of characters for a field name, what does that field name really mean? And breaking out the attributes of it, the abbreviations of it. And so usually there's also some indication of if it's mandatory, conditional, or optional, and that's NINA's way of framing that. and then also some idea of type. If it's integer, double, text string, or blob, that's normally the GIS side of things. NINA uses a slightly different variation of that, which if you're new to a particular project or new to a particular software implementation, sometimes part of understanding the target is trying to understand how their software works and what data it needs and why it needs it and how it uses it. We all may have our own thoughts about what they could have done to improve it or make it better or do it differently. But if that's the software that we're implementing, we kind of need to understand where they're coming from and understand their target. Usually there are also width requirements, and those are usually tied to if it's number or string. And one of the things to look for there is, does all of our data that maps over to that field name, does it fit? Does it run too long? And sometimes the attribution requirements can you leave it blank? Can you leave it null? Does it expect a value there? Sorts of things, or things to keep in mind when trying to understand a target, a new data set that you may be working with. In addition to the tables, some documentation, it always varies depending on the issuing agency or the software provider, will organize things differently, but in addition to those schema tables and layouts, usually providing other helpful sections like, okay, we know you're not used to seeing P in a type column, but here is what P means. It means printable ASCII characters, decimal codes 32 to 126, and kind of lets you know other things with that may help you think about how your data may work in that system, or once your data moves to that format, what you may need to do differently to make it work if it's different, has different expectations than what you currently use your GIS for. So as you start to figure out which of your 3 GIS row center lines you want to use for a project, and once you start identifying or thinking about understanding what your target data source is, or what you need to move your data into, usually you'll get to a point where you'll do a deeper dive of your different field mappings. And it's helpful here to do it at this step to kind of start thinking about sketching out a flow of how your data is going to move and figure out options to help you prepare to make choices. We recommend digging deep in this step because if you miss something or you don't understand something and you make a decision based on what your understanding was at the time, as you move into the plan, design, testing, validation, and you find something new, uncovered, different understanding, different interpretation of how something works, it may mean going back and changing one of your decision points. It may mean going back and recoding something, or adding in other steps, or adding in other tools. So we really recommend trying to understand not just the source and the target, but try to get a good understanding of how your data is going to flow and why your data needs to flow that way to help you make good decisions in implementing your solution. There are a couple different methods for comparing field mappings. The project I was talking about, from my experience in local government, where we had our city addresses and our 911 addresses, one aspect of this project dealt with moving it to our new ERP system, and there was a really detailed schema of addresses in there. But then there was also a second table that included all of those central property addresses, but also included other additional location addresses. And this diagram is roughly to scale. We had about 35 or 40 fields in our addresses for city business purposes. There were about 25 to 30 fields in our 911 addresses. There were 405 fields of attributes in the central property addresses, and I think there were about 11 or 12 fields in the location addresses. And so what we did as we were trying to get our head wrapped around this is we formatted this on a 42 inches wide by 8-foot long piece of paper on our plotter, and just broke out the different schemas that we had and kind of sorted them transposed so we could kind of see the field name, the purpose, the type, any of the requirements. And we started drawing lines from our city addresses through our 911 addresses over to the central property to kind of start seeing how that would flow. And you'll see some notes scribbled on there about, okay, that goes over to number 6, that goes over to number 8, that goes over to number 9. And then as we were trying to understand the flow from the central addresses to these location addresses, it was, okay, well, if we have 406 fields there, which of those flow over there that way? And how does that data flow? Is there anything that, if it doesn't get added to the right table from the left table, that we may want to go in and put in on the back end in another way? And there were a few cases of that where we stumbled into that. But one of the great examples, I wouldn't say it's an example, one of the great things that we learned from this process was that for having a team of 4 folks working on this, having it printed out, having something where we could all look at it, having something where we could jot notes on it, really became the system of record for how we were going to plan the flow of this data. And it was really kind of interesting when I started preparing for the fall trainings. I called up a guy that I worked with on this project that still worked for the locality. Hey, remember that really big piece of paper that we printed this out on and we drew that up? Is that still there? Is that still in the map cabinet drawer over behind the permitting desk? Great, excellent. Happy to hear that is, because that's where the system of record for some of the decisions that we made with this data flow. And he was able to take some pictures and send it to me so we could use it as an example for this workshop. Here's some other examples of as we got into it and started figuring out, if we're carrying this from here, what do we need to code that as? And what are we drawing the statuses from? And what's the system of record for different systems? So it was really helpful for us as a team working on that. So sometimes hard copy, especially if your target system has multiple target data sets that interrelate or feed with each other, may be a good method. And if it's really detailed, sometimes printing out hard copy is a suitable alternative for drawing it out on a whiteboard and trying to understand those requirements. The complete other side to the hard copy is if it's just GIS data, all the answers are already there, especially for your source data. All you have to do is go into our catalog, then right-click. And if you go to right-click properties, you'll see the list of fields. You'll see the field name. You'll see the alias. You'll see the Esri data type. You'll see those other different things. And it's all right there. And sometimes if you just need a quick answer to a quick question, or you knew what it was, but you just forgot it and wanted to double check before you committed to something, so sometimes the other extreme and right-clicking and going from that is a good way to go. But if you're looking at something that has 30 fields, 50 fields, and it's an unfamiliar source or an unfamiliar target, sometimes the carpal tunnel risk and the frustration of doing that many right clicks in our catalog might steer you from that approach. There are some other ways of approaching approaching these, and that also includes using other tools that may help you look at or see or visualize or understand or update what may already be set up in your GIS data. And so one example of this is a tool set that was developed by not by Esri, but by someone that used Esri, called GDB X-Ray, that was built to leverage the XML workspace functionality that geodatabases supported. And so the concept is that if you have a geodatabase or an enterprise geodatabase, you export the schema of that to an XML document. You can load that XML document up into this tool and use this tool to translate that XML into several other reference documents that you can use. And so one of the ones that I frequently use is one that will break down a feature class and give you that table listing of field name, type, length, description, alias name, if there are any domains set up, any default values, those sorts of things, just so you can kind of look at it not in the GIS view, but in the Excel view, and kind of seek to understand it that way. It's also helpful if you're working with domains, and sometimes part of a target may be populating lookup fields. And GDB X-Ray also supports these, where you can generate a master Excel workbook, where each tab in the workbook will be one of the domains, and you can see the coded value and the name that's associated with it. One of the other nifty things about this tool is that if you wanted to add a new value and you wanted it added in alphabetically rather than at the bottom, you can also change it in the Excel, save it, which will go back to the XML, then you can use the tool to work back the other way and turn it into a new geodatabase that would have that new domain table, have those new values in there. And so tools like this, sometimes there are a number of different ways that they can work to help you out as you're in this data evaluation and planning process or maintenance process. Another useful tool that's part of the GDB X-Ray package is that it allows you to create a HTML formatted data dictionary that will go through and list down all of your feature data sets, all of your feature classes, all of your tables, your relationship classes, your domains that appear in that geodatabase. And breaking it out into something where you can easily see an index of it. You click on them, they're hyperlinked, it'll take you down to the different places. If you're looking at a domain, you click on it, it'll take you to that section where it lists down the domain values. That, aside from understanding new databases, sometimes it really helps to be a ready reference for understanding your source data and knowing what you have, knowing what you already have set up. As an easy reference to help you figure out how you're going to move that to your target data sets. So there are some other tools out there, but it is something that does enable you to help visualize and think about the data that's already in your GIS in a different way. As you're digging deeper into your data and your comparisons, we also recommend not just looking at the schemas, but at some point looking at some sample data records from what you already have, especially as you are coming to more of an understanding about what's in the target. And so this split screen view on the bottom has some sample address points from a locality in Virginia. And the top part has some of the field names that are from the NENA GIS data model. And sometimes the field mapping process is seeing how well it works and what other problems we may find that may let us know we may need to do different things. And so if we're looking at house number on the bottom, that's going to map up to address number. AT&T's solution doesn't require us to use the exact same field names, so house number is fine. That's not going to be a problem when we start working with that. Streets. Our locality data has the root street name and the street type in the same field. Need a data model on the top that has separate fields for the street name and the street name post type. Street name is mandatory. Street name post type, if it exists, is optional, meaning, or no, it's conditional, meaning if it exists, it needs to be loaded. So as we're looking at moving from our source data set on the bottom to our target data set on the top, we're going to need to figure out a way to break apart the street name from the street name post type so we can send each of those particular values into the appropriate field in the target. That new system isn't going to like it if we shove that all in the street name. We're going to need to break it out based on what we've learned about the documentation and how that's set up. So those sorts of things, how your data is attributed, if it's the field names and how flexible they are, if they're wide enough, if they're the right type. And that type usually runs in numbers. If it's a number field where it will be used as a number versus if it's a number field that it can pretty much work as text, we see those as differences across some systems. But it's understanding that source, understanding the targets, and starting to work through what that's going to look like, what decisions you're going to have to make to move this data out and move that into those different places. And as you're doing your research and getting up to speed with your project or with your implementation, you'll come to a point where you need to make some decisions. And the NINA data model provides a helpful piece of context here. Increasingly, as more and more software solutions are wanting to be sourced or supplied from authoritative data in GIS, the less likely it's becoming for GIS to completely change out the schema that they're using to maintain their data. Because if you're sending your GIS data to 5 different systems, if you change that schema, you still need to make that data work for 5 different systems. So increasingly, we're seeing kind of this ETL as an option where we're going to change our existing schema in our GIS or master source data as little as possible, but we need to make sure that we can do things to it or add things to it to meet those target data set requirements. So there's a note here in the NINA data model that says it's important to note that an entity need only be capable of exporting their GIS data in a GIS format that meets these schema requirements. Can be handled through use of scripts, field mapping processes, other geoprocessing tasks. So you don't need to change your data. You just need to be able to ETL your data over into something that meets these schema, meets these requirements.
Hey, Matt.
Yes.
Hey, sorry about that. There's a question in the chat room that wants to know where we can find the AT&T ESINet loading specs, like the schema, validation rules, error descriptions, and other interface documentation.
Can we say that towards the end?
We can.
Just don't let me forget it. Okay. So the data model guidance is really set up as, here's what you need to ETL your data into. That being said, if you don't have a lot of dependencies of your existing data, maybe the CAD is the only thing that your GIS data really supports in your locality. It might make more sense just to switch your schema over to this data model or something compliant to it. That's a choice that varies based on locality, but it's really the perspective of, do you want to approach and make the decision to do an ETL once and change out your schema and load all of your existing data into the new schema and use that going forward, knowing that it meets this purpose? Or do you want to leave your existing data as much as possible and just as needed, ETL it out into something that will meet the requirements of the GIS data model that NextGen needs? Those decision points vary for everybody, and it depends on several factors. Usually, as you're doing your research and you're doing your comparisons, you're finding that the schema you need does not match your local schema. Just doesn't. Does the local schema support other business functions? Does your current local schema, your source schema, does it have all the right fields of the right types? Or do you need to add additional fields, carry over the same data as a different type, maybe store a number as text? How many new fields will you need to add in order to populate everything that you may want to, if you want to store in your data to push it over? Sometimes this process gets you thinking about what your local schema looks like. Sometimes your GIS data, if you add a new field anytime you need a field, over the years you might wind up looking like a baggage claim where the baggage is there but none of the passengers are. And you may wind up with a bunch of suitcases that belong to somebody, but that person is no longer there. Or it may just be a lot of institutional clutter, that maybe it was used, that field at one point in time for one purpose, but that's no longer needed or used, or you no longer need to track that for your entity. Thinking about how often it'll need to be used. You know, if you're doing a one ETL versus if it's something that you're going to want to do it once a day, once a week, once a month, may factor into your decisions and how you approach this. But for larger projects like software implementation and needing to source that with GIS data, it's probably going to come down to these two options. One, change your local schema to match the needed schema, and you're kind of ETLing once. And we're seeing some localities in Virginia doing this because that's the choice that makes sense for them with where they're at. Others we're finding are adding fields of the needed types and attributes to the end of their local schema. And then they will plan to use the ETL processes to turn their source data to match their target data schema as needed, monthly, weekly, nightly, depending on what they decide is right for their locality and with their PSAP and their business process. Getting to this point usually helps you understand if it's going to be a smaller project or a more detailed project that you'll need to keep going in maintenance for the life of the system, but also really informs some of the different data techniques that you'll use to complete that ETL. Because if you're going to do it once, sometimes you can do it by hand and you're investing a little bit of time, but you'll get it done, you'll never have to redo it. Whereas if it's a process that you need to do every night, doing all those steps by hand, manually clicking on the tools and running them one at a time, will probably not be the best option or the best path forward. And so by the time you reach those decision points, you're really deciding, is this going to be a one-time thing? Is this going to be a many-time thing? And using that, helping you think about how you're going to plan, design, test, and validate that actual extraction, transformation, and loading from the source data to your target data and your target data sets. And so these are usually based on what you have in your source data after your review and examination of it, the targets, what you need to move that into, the similarities of the schema, and how much you may need to add or in some cases remove from that process, the frequency with which you need to do it, and those contexts will really help guide you into which tools you will use and how you will use them to transform your source data to your target data. Some goals to keep in mind as you're making these choices are accuracy and wanting to pull the appropriate data and transform it in the most accurate way. Simplicity is usually something good to strive for. We can all build bigger and more complicated mousetraps and longer lines of code and use more tools. But if we're accurate, do we really need to go beyond simple in terms of how we do it? Are we able to replicate what we do? If there are 10 steps, are we going to remember to do those 10 steps each time in order? Is it important to do those steps in the same order each time? The speed at which it takes, either manually to click through different options, or to, if you're automating something and running something in the background, how fast does it take the server or workstation to crunch through that and complete those processes or tasks are goals that you may have in mind. And then you may also have a goal of automation, and that may be start from day one with the goal of automating it fully, or it may be working through something step by step with tools and then cobbling them together in a form of automation at the end. But if it's something usually that runs daily or more frequently than daily, usually you'll steer towards or bend towards automation as a goal or as an outcome for your ETL. So when we're talking about the tools that you'll use and how you'll use them, there are three different categories with the extract, transform, and load. And with extract and transform, there are a couple different main categories that we find. On the extract side, some of what you can do extraction-wise can be based on the attributes they have in your existing GIS data. Select all the active rows. Select everything that has a status of this, or select everything that has a length of greater than this, or select all the roads that have names or exclude any of the driveways. All things that can be done with the attributes that you have in your existing data set. Definition query, if you're working through the ArcMap or ArcGIS Pro interface, may have some similar thing could work or apply there. But because it's GIS and we're dealing with data working with location, we also know that there are some spatial-oriented tools or geoprocessing tools that may help us with that extraction. Select by location or clips or identities are all ways of doing that. Would encourage you, though, to think about if you're extracting or doing geoprocessing as part of your extraction based on different data layers to make sure that your data layers have the same coordinate system. If it's the same projection, the same datum, that the layers you're relying to do those spatial operations on are already lining up. And we're not introducing error by using different coordinate systems, projections, or datums in those processes. I have view on that list, mainly because sometimes if you're using more of an enterprise SCE environment and you're pulling and pushing data in different ways and formats, you could also set up views based on attributes or geometry. That may help you pull out that subset of what you'd like to do from your source data for your ETL process. So an example of this that we're seeing with the NextGen project is that the localities can only send in GIS data to the ESINet that falls within their provisioning boundary. And so their provisioning boundary is kind of their footprint of GIS responsibility. And so here we have our provisioning entity is the gold one, and one of their neighboring entities is the gray one. Now, the yellow localities, road centerline data set that they have locally, extends out beyond their provisioning boundary because they have some roads that go outside just because when they make maps or when they're looking at it in CAD, they need that context of what goes on outside of the locality's boundary. And so they have that in their data set, but they don't need to send those roads out in the gray area into the ESINet because it's their neighbor's responsibility to do that because it's in their neighbor's provisioning footprint. So the ETL choice on the extraction side that the yellow provisioning entity locality will have to make is, I have these roads in my data set. I still need them in my data set. I need to use them locally. I can't send them to the target data set. It's not my responsibility to. The system will throw an error if I do it. What process do I want to use to make sure I only send the roads that are within my provisioning footprint and I exclude those that my neighbor's going to send? If they have an attribute flag that says, this is my locality, this is someone else's locality, they could do that select by attribute and select those down and then carry on with their subset of that. If they don't and they don't want to add one, then something like clip or select by location where the road segments are completely within the provisioning polygon of the entity may work and start as that point of departure to get that subset of the data. And either of those, the choice of which tools and which combination of tools really depends on the locality, what's in the data, what's in the source data, how accurate it is, how well it's maintained, and how you may want to cobble these different tools or techniques together to achieve your ultimate goal of extracting the appropriate data. Transformation tools also tend to fall into the same differences. Some tend to be more text-based, based on attributes that you already have in your GIS, and you're carrying those over to other fields through a field mapping process. But there are also ones that tend to be more spatial in how they work or how they operate. And so especially if you have data that comes in as a flat file and has a latitude or longitude, but you want to turn it into a point. Maybe you have data as a polygon, but the target data set really wants it as a point. Maybe in order to get some attributes from one that I saw in local government was we had an address and we needed to know what city council ward it was in. Well, the easiest way to do that was to do a identity geoprocessing, where we'd start with our address points, we'd push them through the ward polygon layers, and our output would be the address feature class table schema. And then it would have on the end the additional attribute field of what ward it fell in, if it fell in a ward. And so those are strategies there for that. If it's on the table side, sometimes it's splitting or concatenating values. Do we have the street name and the street type in the same field? Do we need to have them separate? Do we need to have them combined? And the relationships of what you find in the source and what you find in the target will help you decide those. Table joins based on attribute values is also sometimes a helpful way if you don't already have a attribute that you need in your source data, and maybe you don't want to add it and store it there, but you at least need it there temporarily to get it in as part of the load. Then sometimes a table join to bring that in based on a unique identifier may be a helpful way to do that and still keep your source data clean. Some examples of different techniques. This from the project that we were looking at before, where the addresses wanted it wanted a flag for the address if it was city-owned property or government-owned property. And so we contemplated doing an overlay analysis with our city-owned property layer. And then if it was a rental property, and based on how the rental information was, we went about it as we selected all of the parcels that had an active rental certificate. And then if any of those addresses overlaid with one of those parcels with an active rental certificate, that got flagged for the purpose of the new system. And so geoprocessing and overlay analysis is sometimes a helpful way to transform data and add data in, especially if it doesn't line up one-to-one. On the text side, something that's come up quite a bit as Virginia localities have started to work with the NINA data model there's a requirement for a global unique identifier. And this was a concept that as when Virginia developed their data set standards before the NINA data model was approved, there's an element of having a local, unique and persistent road center line ID, and usually a really good idea for all your data sets. With the introduction of the NINA data model, it requires a globally unique ID. And so this means not just what you have in your road center line data, but any road center line segment that's uploaded into the EZNet. You can't have any duplicate IDs regardless of who or which entity uploads it. And so the NINA guidance is if you have a unique and persistent local unique ID, and the example here is maybe that 6237. They give the example of, well, let's put RCL in front of it so we know that that's road center line. And then to make it unique, let's append at, and then the 911 authority's domain address that's used elsewhere in the NG 911 system. Let's append that to the end to make sure that we keep all of those RCL number segments separate. And the idea here is that being able to look at that domain at the end It'll make sure it's unique, but it'll also be a little bit more readable and intelligible, maybe than a combination of a state and locality FIPS code, which we also sometimes see done. And the field for that is 254 characters text, and so having that sort of format in there would work. AT&T's version interpretation of that, they're kind of following the NINA guidance. It is feasible if you just had a feature ID and then maybe you added your FIPS code in front of that or behind that, you still may get duplicates. And that's something that the NINA recommendation is trying to work around. Why this makes a great example for transforming is that you probably don't want to add RCL in front of all your feature IDs, which might already be a number in your existing data set. And you may not have that set up as 254 text characters wide. And so you may not have room to fit all of that at 911 authority, domain, state, US in there. But if you have that feature ID, and you've extracted that data, it would be really easy to temporarily add on a new field, append RCL to the front of that, and concatenate on the domain at the end, and take care of that all on the text side. So with the data set that you do load up into the ESINet, all your data would look like that without clouding up your source data. One of the other things that we're seeing, particular to the data model, is that it has a building field and a unit field, and the expected values in there are building A or apartment C. Why this makes a good example of text transformations are that usually in our legacy data, we're going to see something like a unit field and a unit number field. Apartment in one field, 105 in another field. Apartment 114. What the NINA data model expects is in the unit field, have apartment 105 in there. And so that's something to where there may be a choice to be made. Do we want to add a NG911 unit to our source data set and concatenate those on the back end and just carry that through? Or is that something as part of our transform process? We want to have a step, add some code where if it's apartment APT, we change that to apartment spelled out, and we add in the value from the unit number for that field. So there's an example there of where transformation may be helpful. The loading may take a variety of different appearances as well. Sometimes for some projects, you are appending new features to an existing GIS feature class or data set. Sometimes you are copying features from a working space data set and pasting it into a new one. Sometimes you are deleting and replacing all of the records in a data set and replacing them with new records, or deleting the entire feature class and recreating the entire feature class. If we're looking at services, overriding the service, republishing the service. Sometimes it may be, it doesn't want a GIS file. Maybe the wanted export is an Excel file or a CSV file. Maybe it wants a GIS file, but it wants it zipped up for uploading or some other thing. And so usually what we find is understanding the end target kind of helps you get through the transform. It may change some of your decision making, though, in terms of what that load decision will be and how that may play out. We do recommend, as you're planning, designing, testing, and validating, usually it's useful to design or use a target shell. And so having an empty feature class or schema that represents your target data set may be more helpful than just building it as you go along or building it from scratch. Sometimes it's also useful if your transformation process is joining in a bunch of attribute fields, or you're doing a bunch of geoprocessing overlays and you're getting even more fields that you don't need. appending data into shells will strip off some of that processing baggage, and tends to be more efficient than going in and deleting fields. On the NextGen 911 side, on the same page, NINA page that you'll find the GIS data model PDF, there are 2 new documents on the bottom. There's a NINA Ref 006.1 and a NG911 GIS template files. NINA put together a work group that put together a geodatabase template and a open source GIS template to help serve as this blank schema. And so if you'd like a target to use to try to move your data from your source into it as a target that's already built out based on the fields of the data model, that is up there and available from the NINA standards page. One of the other resources that VITA is working on to help assist localities in this is with our report card tools. We're in the process of updating the tool set, the documentation for the tool set, but the new version, which we'll have done this month or early next month, is going to have a few additional tools on there where if you run the additional scripts, it will add in all the fields to the output that you need to support the NINA schema. It will populate some of those based on what's in your source data in the field mapping script, but it at least gives you your data in a format to where you can kind of work to plug in the holes or come up with ways to plug in some of the holes that you may have to meet the requirements for the target data set. So if we're putting all the pieces together, and just as a hypothetical example, so we're going to need to download our provisioning boundary polygon from VITA. We're going to project and transform that to match our local data projection and datum. We're going to use the select by attribute of our active road centerline segments because we only want the active roads going up to the EZNet. We don't want any paper roads or removed roads. Then we're going to clip those active roads to that provisioning boundary. We may add a field and give it a new name to hold that new global unique ID field. And we can populate all those in the data set with field calculator or something like it, using the RCL and then pulling in the value from the unique local ID field and then a domain on the back end. There may be some other attributes that we're currently tracking or using that we may need to update because they're not supported in the target. One of these may be if you have mixed parity on your road center lines. And so you have maybe locally you code parity left as OE for odd and even, but the NINA data model and AT&T don't support that. If you have mixed parity on the left side, they want it to be B. The data model expects B. So maybe as part of your transformation, you select anything that you have attributed as OE and you change it to B. Also on the parity side of things, if you have 0-0 address ranges, parity there, according to the data model, is supposed to be Z. And so maybe as part of that transformation, you go through, select all of the address ranges that are 0-0, and then calculate the parity to be Z for that value. You do those and other steps. You export those features as a RCL feature class. I put a date on there as to when we created that, and we're going to save that into a new geodatabase following a similar naming convention. We're going to do our similar ETL steps for the other data layers that we need to upload. Then we'll zip that geodatabase up into one zip file. And then as we log into AT&T's UGDMS system, we upload that newly created zip file, and that completes the extraction from our data through several steps and loading it up into that target data set, the AT&T ESINet. Is the best practice, especially as you are planning and executing and implementing your ETL. It's always good to remember to validate that what we ran through our processes or steps or scripts does what we want it to do, that all the fields that we expected to populated, and they did in the way that we expected. I know that all of us probably at some point or another have done a table join from one data set to another data set. And instead of seeing from that second data set all of those fields attributed and showing up after the join, they were all null or they were all blank. And so especially if we're leaning towards doing something programmatically or loading data, making sure that the output of our ETL meets our expectations and our results. So some thoughts on automation. There are a number of software tools that would help you automate that work within an Esri environment or outside an Esri environment. And there are also costs and benefits of doing it manual, doing it scripted, doing it more fully automated based on the number of times you need to do it, learning curve to execute those methods, the time it takes to do any one of those. Where we tend to recommend more modeling or Python scripting approaches is if the process needs to be repeated often in the same way, in the same order, to get consistent results. It's usually good because the scripting will enforce that order and enforce the process in the same way. It's also useful if we're transforming attributes to meet new requirements. If you are working with larger data sets, you also have the ability in the Esri environment to do the processing in memory rather than writing to a physical file or a new feature class or a new shape file at each step through the process. And that cumulatively, if you're doing multiple joins or multiple overlays, will save you time by doing that in the memory of the workstation or computer or server that you're working on. While it may take more time to set up initially, modeling and Python scripting will also be faster in the end as it saves you mouse clicks. If you think about in ArcMap, it may take you 10 clicks of a mouse to load up and run any tool. It may take 30 clicks to set that up if you're going to put it in a model builder or a Python script the first time. But if you run that model 3 times, you're even on mouse clicks. And you know it's going to be done the same way, the same process each and every time. If you're new to scripting and want to see NextGen as an opportunity, as an example to work with that, or you're looking for other pointers or examples, VITA has developed field mapping scripts that we use internally as we receive the 132 localities GIS data and integrate them twice a year into our address point and road center line data sets. And we do make those available as part of the report card tools because field mapping is part of how these tools work. If you're loading up your data in your local schema, we need to translate it into something common in order to make those tools work for us. And so for each locality that we have, there's a script that runs as part of this where it translates what the local values are and populates them into the Virginia standard values. And some of them are fairly simple field mapping scripts. Others may get a little bit more lengthy. So this one is dealing with selecting unit types and doing some pre-selection parsing, cleaning up prefix directions and full street names. And so there's some examples there where if you're looking for ideas for your own localities or some of what what VITA's developed based on what we see in the data of other localities of examples to use. If you go more the route of scripting, there are also some advantages to scheduling batch scripts. And so Windows batch files can easily be configured to run multiple Python scripts in particular orders, write log files, and take other actions. And you can schedule these through the Windows Task Scheduler. If you go this route, we recommend thinking about if it's going to hit production data, and if other users may need to use that production data while the script is running. And so the idea of having off-hours data maintenance windows that you publish and make your end users aware of is a good idea. If you're running it on a server, thinking about an individual user versus multiple people, maybe needing to tweak that script or schedule that script versus having a non-individual user programmatic credential set up in that environment that has the permissions to execute, run, and save those scripts. Error handling is also usually recommended if you're taking that step, especially if you get an email, if something went wrong and you check your email first thing in the morning. Esri's release notes for ARC Pro 2.5 discuss that they have now added some scheduling functionality into that version of Pro. I have not explored that, but just wanted to point that out, that's a functionality that is now being incorporated into some of those Esri toolkits, but can't comment on how well those work or how easy those are to use. So what we've tried to do for you today is kind of walk through the process of the concept of ETL and some of the best practices that we recommend and other folks that do ETL beyond GIS practitioners recommend in order to understand what the source and targets are, the process of making decisions and laying out a plan, executing it, and then taking next steps towards automating it. We know that everybody that's looking at NextGen 911 as a project is involved in aspects of this conversation, if we're calling it ETL or not. But it's also something that GIS folks do all the time, and we may not always think about it as ETL. And so we wanted to assemble some thoughts and perspectives, best practices and recommendations, tools, tips, and strategies, and some interesting things we found in the NINA data model as another way of thinking about what we do as GIS professionals and how these tools work. So, Melissa, I know a few questions have come in that we need to answer as we're wrapping up. I think that the question that was asked before is, how do folks get the AT&T version of the data model requirements? Is that correct?
Yes, that is. Where can they find the AT&T AZNet loading specs, the schema, validation rules, error descriptions, and other interface documentation? Okay,
so the NINA specifications are on the NINA website, and if you Google NINA standards, you'll find those. AT&T's user guide is provided as folks start working with AT&T as part of their GIS project, which happens after localities have their funding, after they sign their participation agreement with AT&T, which means that AT&T has their vendors start working with folks, and as the timeline to start that project comes up as part of the overall project plan. Everything that we've seen in the AT&T documentation is also in the NINA data model. What other questions did we have?
Okay, and it may go along with what you just answered, but there was a question related to that or from the same person. What do we do with the known exceptions, for example, where we have a mixed parity?
So if it's mixed parity, you would want to attribute that parity as B, which means both in the NINA data model schema. It's acceptable. Okay. The real world is messy. We know it happens, but the NINA data model's standard for handling that is to attribute that mixed parity as B.
Okay. We also, for those folks who do not have ESRI licenses, is there a geocoding API available that is non-ESRI?
There are many different geocoding APIs available from a number of different sources, some ESRI, some not. OpenStreetMap API is one that is out there as well. I do not believe, and I would have to double check and verify that VIGIN does not publish. You might be able to access our geocoder from non-ESRI programming protocols and more open source protocols, but don't hold me to that. I do know that OpenStreetMap and some of those other folks routinely incorporate or use the data that VIGIN publishes, address points and road center lines, to update their data, to update their geocoders whenever we push on updates.
Okay, and so a question was, so all exceptions have to be transformed or dropped?
All exceptions?
Yes, that's what the question is. Data exceptions.
So, so in the context of NG911, there are a few exceptions that the AT&T solution allows. The goal is having your GIS data accurately represent your real world ground condition, and then be able to model that in the different ways that the standard allows, so that when we load that data in the NG911 system, it is performing based on the best available GIS data that accurately represents real world ground condition. What that means is that, yeah, we may have to have an exception or two in there, but the standard is really robust in what it allows and what we can send in and what we can tell it about weird stuff, like parity is the example. And so those are things to where if you have an exception now, it might be worth looking at, well, why is that an exception? And will that same exception apply in the NINA data model? Or what other ways are there sending that type of information in based on the NINA data model? For the person that asked that particular question, if you have specifics in mind or specific examples, feel free to email me, and we'll set up a time to chat and kind of walk you through some of what you may have and what you may be concerned about.
Okay, and also looks like just a statement, maybe Excel VBA has scheduling and also documentation on interface usage.
Okay. Definitely there are other programs, non-GIS, non-database, non-script programming that do allow different elements of ETL work and transformation using a variety of different languages. VBA in the Microsoft Office platform, if it's Excel or Access, certainly does some of those things. And there are a lot of options out there. We can't talk about all the options. We'd run out of time. But what we did want to do is highlight the most common ones that we see currently from the GIS side, and the ones that may be most useful for folks working with GIS tools.
Okay, looks like that's all of the questions in the chat window. If anyone has some questions, I can unmute you, or you can use *6 to unmute yourself. If not, Matt, do you have anything else?
Hopefully this was useful information and provoked a lot of positive thought about how we approach projects and moving data from one place to another. Please keep the conversation going. Reach out to your regional coordinator or myself or other folks of the ISP team. If you have questions, concerns about these types of strategies, not just with NextGen 911, but it is something that we know local government runs into all the time. And every once in a while, we're happy to talk through use cases and problems that aren't NG 911 related. So be happy to hear from you, and thank you everybody for attending today.
And also, Matt, we had a question about would we be sending out this PowerPoint. This presentation will be posted on our YouTube channel as well as our website. And as you've joined the webinar, you should get a link within the next, I don't know, 30 minutes to an hour with the replay of this. So if you don't, please reach out to myself or Matt, your regional coordinator, or whoever you want to contact with ISP, and we'll get that presentation to you. But it should be posted. You should get a link for replay. We appreciate everyone joining our webinar Wednesday series, and we look forward to announcing the next webinar. Thank you, everyone, and have a great day.